Hi everybody. Hello. Okay, so we are going to take a look at Chapter 7, electric charges, electric fields, and we're going to take a look at example from the PowerPoint regarding electric forces. Okay? Okay. All right, so we are taking this example from the PowerPoint. We're taking a look at 3 different particles, and we're going to be using vector components to solve for it. And now remember what we said about electric forces, that between any 2 particles, my formula is K Q1 Q2 divided by R squared. Okay, and this is of course measured in newtons, and Q and Q1 and Q2 are my charges. This is what we've done so far. So my example has 3 particles, and my particles are 1, 2, and 3, and this right here is 30 degrees. That is your angle. And Q1, Q2, Q3, keep on pressing this button. Okay, so this is Q1, Q2, and Q3. And Q1 has a charge of negative 5.0 times 10 to the negative 6 coulombs. Okay, so this one right here is negative 5.0 times 10 to the negative 6 coulombs. Okay, this right here is 2.0 centimeters. And this right here is 1.0 centimeter. Okay, and Q2 is negative 4.0 times 10 to the negative 6. So negative 4.0 times 10 to the negative 6 coulombs. And Q3 is 3.5 times 3.5 times 10 to the negative 6 coulombs as well. Negative 6 coulombs. So they are my 3 charges. And the question is asking us for us to calculate the net force on particle 1. So what is the F net on Q1? Okay. Now when we're doing this question, the first thing we're going to do is take a look at how my forces are, repulsion and attraction between all the charges. So we have negative and a negative charge. So between Q1 and Q2, which way is my force going? To the right or to the left? To the left, because I am being repelled. So this is going to be FE or FQ12 going to the left, a repulsive force. And this force right here, this is a force of attraction between your negative charge and your positive charge. So is it going diagonally downward or is it going upward? Downward, so it's going to be like this, F13. So basically I've got this plus that, which gives you F net, which is going to be like this. This is going to be your F net. And we're trying to figure out what F net is. And this right here is 30 degrees. Does that make sense? Okay. All right. And that's that. So the first thing we're going to do is figure out my F12. So F12 is going to be, in terms of calculating, K Q1 Q2 divided by R squared. Of course, K is 9.0 times 10 to the 9. Q1 is 5.0 times 10 to the negative 6. Now, as we said, that this is absolute value. My Q's are an absolute value, so all the values always turn out to be positive. And this one right here is 4.0 times 10 to the negative 6 divided by 0.02 meters squared. And of course, R is always in meters. Okay, so what do you get for your F12? Now remember, F12 is in the X direction, so this is going to be F12X. And what do you get? 450. So 450 newtons going to the west. So far so good? Going to the west. Okay, so the next thing that we're going to do is we're going to figure out what my F13 charge is. Okay, so my F13, and that's going to be again K Q1, Q3 divided by R squared, and that's going to be 9.0 times 10 to the 9. Q1 is 5.0 times 10 to the negative 6, and then 3.5 times 10 to the negative 6 divided by 1 squared, 0.01 squared. It's 1 centimeter. And what do you get for your F13? So 1.5 okay, newtons. All right. Now F13 has two components, and those two components are this and that. So that's going to be F13x, and this is going to be F13y. Okay, and we've got to, of course, do this in terms of vector components. Okay, so when I'm doing my x and y components, my F net x is going to be made up of F12x plus F13x. So far so good? Okay. Well, F12x we've already calculated. So F12x right here is 450 newtons, and that is going west. F13x is going to be 1575 newtons, and that is going to be cos of 30, and that is going to be going east. So can somebody tell me what that is? What is 1575 times cos of 30? And you get 450 west, and of course it's going to be minus. What is 1575 cos of 3? 1363, 64 newtons going to the east. Of course we're going to subtract the 2. So your F net x comes out to what? Your F net x comes out to, in the easterly direction, 913 newtons going east. Are we good? So far so good? Okay. Now we're going to do the exact same thing for my y component. Can I erase some of this? I'm just needing more space. Are we okay with these numbers? Okay. All right. So I'm going to move this up, and let's talk about F net y. Now F net y only actually has one component in it, and that's going to be F13y, because F12 is only in the x direction. So F13 is 1575 times sine of 30, and that is going south, correct? It was going south. What do you get for your F13y? 787.5 newtons, and that is going south. Okay. Now we're going to find our Pythagorean, and you end up with F net, which of course equals to f of x squared plus f of y squared, and you get square root of 913 squared plus 787.5 squared. And what is your F net? So 1206.5 newtons. And what direction? What is my theta? Tan inverse, of course, opposite over adjacent. And your diagram is going to look like this, east and south. This is going to be your F net. This is f of x. This is f of y. Okay, so it's f of y divided by f of x. And what is your theta? How many degrees? (41 degrees south of east). Are we okay with this? Any questions? So again, we just did vector components. Yes, it was in terms of electric charges, but we didn't do anything special. We didn't This is exactly how we've been doing vector components from the beginning of the chapter, from the beginning of the course. So as long as you remember vector components, I don't want you to get frazzled by your electric force. We're just saying it's a repulsive or an attractive force, but at the end of the day, the way to solve it is exactly the same. Find the force, figure out the components, add and subtract Pythagorean. Are we good? Okay.